Hello friends, in this video, let us discuss about hashing and collision. So what is hashing? Hashing is an efficient method to store and access elements. It's exactly same as index page of a book. In the index page, every topic is associated with a page number. If we want to look for some topic, we can directly get the page number from the index. Likewise, in hashing, every value will be associated with a key. Using this key, we can point out the element directly. In this video, we will learn how hashing improves searching performance. Let us take an unsorted array of 8 elements and perform linear search. What will be the worst case time complexity? That is, finding the element 123. Since the array is unsorted, we need to traverse the whole array to find the element 123. Here, the array has 8 elements and the time complexity will be order of 8. And in general, if the array has n elements, the worst case time complexity will be order of n. Now, let us take a sorted array of 8 elements and perform binary search. Now, what will be the worst case time complexity here? Let us search for element 45. Here, we will divide the array into 2 and search the key in one half only and ignore the other half. This is done in each step. That is, find the middle element first. It is 70 and the key 45 is less than 70. So we need to search in first half only. Now find the middle element again. It is 23 and the key 45 is greater than 23. So search in second half only and it is found here. So in each step we are reducing the search space into half. That is, first we have n elements, then n by 2, then n by 4, then n by 8 and so on. So we will get the time complexity as order of log n to base 2. So if the array is sorted, the worst case time complexity is order of log n to base 2. That is, here it is order of log 8 to base 2, that is order of 3. Now the question is, can we improve the time complexity even further? Can we search an element in order of 1 time? The answer is yes, we can. We can do it using hashing. Let us take a hash table of size n and the elements 2, 4, 6 and 8. The simplest method is placing the key in the exact array index. That is, using the function f of x equal to x. So when x equal to 2, f of 2 is equal to 2. So place the element 2 in index 2. When x equal to 4, f of 4 is equal to 4. So place the element 4 in index 4. When x is equal to 6, f of 6 is equal to 6. So place the element 6 in index 6. And similarly, when x equal to 8, f of 8 equal to 8. So place the element 8 in index 8. And if we want to search the element, we can directly find it using the same method. We have f of x equal to x. So if we want to search the element 8, we have f of 8 equal to 8. So search the element 8 in array index 8 and we have 8 here, so the search is found. And if we want to search the element 7, we have f of 7 equal to 7. And in index 7, we don't have the element 7, so the search is not found. But there is a major drawback in this technique. Let us find what it is. Let us insert the element 100. So f of 100 is equal to 100. So 100 will be placed in the index 100. And just because of this one bigger element, we are wasting so many bytes of data. So this is not a space efficient method. So what can we do? We can reduce the space using the modulo operator. As we know, when we use modulo n operator, the output is always in range of 0 to n minus 1. For example, let us assume n is equal to 3. Let us take a number 0. 0 more 3 is equal to 0. 1 more 3 is equal to 1. 2 more 3 is equal to 2. And 3 more 3 is equal to 0. 4 more 3 is equal to 1. 5 more 3 is equal to 2. If we absorb the result, it will always be in between 0 to 3 minus 1, which is 0 to 2. So we can change our method using the modulo operator so that it will always provide the index within a range. So we can effectively save the space. The new method will be f of x is equal to x mod size. Here, size indicates the hash table size. Let us understand how we can store and retrieve elements using this method. Take hash table of size 7. Initialize it with -1. -1 indicates element is not present or the particular index is available to insert. Let us understand the insert operation first. We have key is equal to data mode size. If the element to be inserted or the data is 24, where should we insert it? We can apply it here. Key is equal to data mode size, that is 24 mod 7, which is equal to 3. So insert 24 at index 3. And to insert 8, we have key is equal to 8 mod 7, which is equal to 1. So 8 is inserted at index 1. And to insert 14, we have key equal to 14 mod 7, which is equal to 0. So 14 is inserted at index 0. So that is how we insert elements. Now let us understand how search can be performed. We can perform modulo size operation on the element to be searched and we will get a key. Then we can go and check there. And if it is there, it is present, and otherwise it is not. For example, let us search for element 8. So key is equal to 8 mod 7, which is equal to 1. So go and check here and we have 8. So the search is found. Now let us search for element 19. So key is equal to 19 mod 7, which is equal to 5. So go and check here, and here we have -1, which indicates the element is not present. So the search is not found. Now let us discuss about deletion operation. To delete an element also, we have to first find the key. So let us delete the element 24. So first find the key, and we have key is equal to 24 mod 7, that is equal to 3. So go to index 3 and change the value to -1, and the deletion is completed. So that is how we can perform insertion, searching and deletion. Now what is collision in hashing? Let us insert the element 15 in this table, and we have key is equal to element mod size, that is key is equal to 15 mod 7, which is equal to 1. That is, the element 15 should be inserted at index 1. But index 1 already has the element 8. So here, 2 or more different elements are pointing to the same index under modulo size operation. And this is what is called collision. So how can we handle this kind of collision? Let us learn how to avoid a collision in the next video. So today we have discussed about hashing, which is an efficient method to perform searching with time complexity order of 1. We found the space wastage problem and we did solve it using the modulo operation to get a key within the range. And we also learned how to perform insertion, searching and deletion. And we just had an introduction to collision. In the next videos, we will learn about collision resolution.